inverse functions now. So inverse functions, I want to start talking about inverse operations. And you guys will hopefully remember this from last year, so we can hopefully fly through it pretty quickly. But we've worked with inverse operations all year long. Inverse operations are pairs of mathematical manipulations in which one operation undoes the action of the other one. And if multiple operations are listed, the inverse must be determined in the opposite order it was given. And this will make more sense in a little bit. So, but if I had like here, and we'll actually get to that. So remember that it's in the opposite order. Whoops, that it was given. Okay. All right. We want to do a couple of these. Write a function f for the given statement, then write an inverse operation for the following statement, and then represent the inverse as a function g. I don't really love all that, but so what's the inverse operation of multiplying by 20?
Dividing by 20.
Yeah, dividing by 20 is the inverse operation. So me taking this and dividing by 20 is the inverse operation. Now they wanted you to do more. So like if I had f of x and I had something x that was times by 20, if I wanted to undo it, I might have g of x that was actually me dividing by 20, which I'm going to technically just do a 120 times x, okay? So what's the inverse operation of dividing by 3, then adding 7? So let's write what that function would look like, okay? If I had something x that was dividing by 3 and then adding a 7, we do in the opposite order is what it's saying. So what would we do first? Subtract a 7. Remember this when we go to find inverses. Subtract 7, then what? Then multiply by what? 3. So g of x would be us subtracting a 7. So I would be taking my x, and I would have subtracted by 7, but then I would have times by a 3. So it's in like the reverse order of that. We're actually going to get to inverses a little bit better in just a second. Multiplying by 5, then subtracting by 6. If we do stuff in the reverse order, it's actually what?
Subtract by 6 and multiply by 5.
Careful, it's opposite operation. What undoes the subtract 6? Add 6, right? Then divide what? Divide by 5. Whoops. Okay. So if my function had been having me take like my x and times by 5 and then subtract 6, its inverse would have had me, we said add 6 and then times by a 5. All right, we're going to go ahead, or did I say divide? Oh, divide by 5, because I was multiplying by 5, so I'd have to divide by 5. I'm like, those don't look like inverses. Okay. We'll get to that in 1 second. Let's try and do some notation, symbolization. You guys remember this from last year, I hope. If f is a function and its inverse is, we use a little superscript, and we use a little -1. That's not an exponent. So don't mistake that for an exponent at all. That's a notation. So if I wanted to talk about f versus f inverse, I use a little -1. If you guys notice on your calculators, those of you who have, who has my calculator today? Will you guys make sure you're leaving a cell phone, please, if you take these? Otherwise, we won't have them in class for you. You have to go buy your own. So please don't take them without leaving a cell phone, because I've had them so missing. If you guys look at your trig functions, there's a little superscript of a -1. And it's because they share a button with their inverse function. And so this little superscript stands for inverse. So those of you who have these T's, perfect, thanks for telling me that. And then if you need it for today, you can keep using it. I've had like a bunch go missing, and I'm going to stop having them enough out. So anyway, let's go ahead and talk about this really fast, okay? A function is, so right here, an inverse function of f, which is symbolized f inverse, is the function containing all the ordered pairs of f with the first and second coordinates swapped out. Everything with inverses essentially swaps your x's and your y's. Everything with your x domain column will switch out with everything in your output y column. So everything that was an input on f is now an output on f inverse. So everything is just swapped. Really, really, really easy to understand inverses. For example, if f has AB as an ordered pair in its graph, well, f inverse will have an ordered pair BA. They just are swapped. Don't switch signs or anything. It's just swapped x's and y's. Nothing with like Even though I don't want you to mess around with like the operations were opposite. Literally the ordered pair just gets this swap. Okay? This is really important. The domain of F is the range of F inverse and vice versa. So if I know the domain of something, I can do the range of the other one. So therefore, if I know the range of this one, I know the domain of this one. So they match. So let's talk about F, and let's talk about F inverse for a second. Domain and range will match. And then this one's range, hold on, F's domain and range. Okay, this one's domain matches this one's range, this one's domain matches that one's range, okay? With F and F inverse. Really, really easy to kind of map these out. So, I could give you stuff as an ordered pair, and we'd want you guys to be able to evaluate what's what. Let's go ahead and list the original domain of F. Will you guys list whenever you guys do a list, go ahead and just do a set, okay? Will you guys give me the set that represents our domain for this specific function? It's not like an interval. You have to give me the distinct points, okay? Give me the domain. Input values, right? Your input values is your domain. So give me your input values.
0, 2, 4, 6, 8.
The input values is the domain. So your x's,
0, 1, 2.
yeah, your x is your domain and your range is your, okay, 0, 1, 2, 3, 4. And the range, you guys, 0, 2, 4, 6, 8. Okay? Well, now I'll complete the table for F inverse. So let's fill out the table for F inverse right here. What would you guys put into your x's? Yeah, 0. We just swap them, 0, 2, 4, 6, 8. And you'd have 0, 1, 2, 3, 4. So everything with their x's and their y's is swapped out. So when you guys switch your domain and range, you now just get to switch. I don't know why it's not erasing for me today. Huh. Can't mess up, I guess. So we just swap out that set, your domain for the inverse. And sometimes we'll notate a little superscript -1 on the inverse's domain. 0, 2, 4, 6, 8. And your range is obviously all those that used to be the domain. Okay? Super, super straightforward. Who remembers this from last year a little bit? Awesome. I hope it comes back to you. Let's read and evaluate stuff with inverses and whatnot. This isn't any different than the tables we just did on compositions. As long as you understand which one's which and we go to the X and we do the input. If we're understanding input versus output, you guys will be just fine. Okay? So this one's asking us to look at which table? F's, the first one. So everybody go to F of 2. What's our output on that? 4, good. Everybody, this one's asking us to you which table? The second one, the inverse table, right? Will you guys take a moment and find F inverse of 2? It's at 1. Good job. You can also go to F's table. What if I didn't have this table written? What if I hadn't even given you guys this table and I asked you guys to do F inverse of 2? What could have I done? I could have gone to the output column and worked backwards. I could have gone here to 2 and then realized it should be a 1. Okay, so you guys, if we didn't even organize those tables, hopefully you guys would be able to talk with that. All right, let's jump to the next idea. We hope it's being weird again. Dang it. I don't know why it's being weird. And it's not letting me erase, so there is a problem. I might have to close it and open it, maybe. Let me close this and open it. Sorry, guys. Okay, I got my tech working again. Okay, to have an inverse F inverse. Okay, let's go ahead and talk about this. For something to have an inverse, as is, it has to be a one-to-one function. This is kind of probably new to you unless you're in honors. We didn't talk about one-to-one functions in regulars last year. No two elements, but we do see this in 1050. No two elements in the domain of F can correspond to the same element in the range of Y. For example, so is example 2, go back to example 2, just a second ago. Is example 2 a one-to-one function? Do you guys see anything that maps on like from in the range to the Y and then the Y to the range like twice? Does anybody see anything twice? Or do you guys think it's a one-to-one function? Yeah, it is a one-to-one function. Okay, a function is one-to-one if its graph passes the horizontal line test. So we've done a vertical line test to decide if things are functions in general. So for instance, this one right here, it passes a vertical line test, so it tells you it is a function. But because it doesn't pass the horizontal line test, it is not one-to-one. So as is, it doesn't have an inverse unless you restrict its domain. Because it goes twice, okay? You have two outputs on the y two different x's that have the same output on the y. It has to be one-to-one, okay? So even though it is a function because there's no two x's that have the same y, but we also want to have this no double y's. No y's have the same, I don't want to see y at like 3 twice. Does that make sense to everybody? So this is called the horizontal line test, and no horizontal line can pass through the graph. What we would do in this scenario is we would restrict the domain and then find its inverse with a restricted domain so that now its graph would be a function. That's a square root function. We have to restrict its domain. If we had graphed quadratics inverses like as is, it would have looked like this and it wouldn't give us a resultant function. And so you guys, it has to pass the horizontal line test to be able to be one-to-one. So is this one one-to-one? Yes. Is this one, so no here, yes here. Was this one one-to-one? No, because I could plug in two different y's and get the exact same output, right? Two different x's gives me the same output. You can ask me a question. Yeah, this is a 4th degree, right? So it could cross 4 times, and then Aiden?
So if it's odd, then it's a yes. If it's even, it's a no.
Technically, yeah. Because they have to have same end behaviors, right? You gotta be a little bit careful. Let me think of a scenario. But yes, in short, yeah, even and odd functions. Odd degrees. I shouldn't call them even and odd because that means something different. But odd degrees work out this way. Okay, awesome. Is the function as an ordered pair? Can you guys tell if it's one-to-one? Yes or no, do you guys think?
Yes.
So sometimes it helps to like jot these on a graph. -1, 5, 0, 6, 4, -2, right? And then all of a sudden -5, 5 again. So it doesn't pass the y. So I have two y's that have the same output. So it is not a one-to-one function. All right, so this one would not be. Okay, all right, how many of you remember that because if I have a value over here at AB, let's say I have a value here at 2, 3, then I would have a value on the inverse at 3, 2. Okay, inverse values, you just can flip up all the x's and y's. They are reflected over the line y equals x. Who remembers this a little bit? Okay, if you guys have a graph, all you have to do is flip out all the x's and y's and now you have the graph of this inverse. It's really easy. Inverses are essentially a turned and flipped version of each other. Okay, that's what they really are. So if I kind of turn something 90 degrees and I flip it, that's an inverse. And you should be able to fold inverses over this line y equals x, and they should like line up with each other. So you know you sketched something correctly if that happens. So let's go ahead and just get the graph of a couple inverses. This one's super easy. This one is a little bit like doesn't look like it's coming together, and then all of a sudden it does. So let's do them both, okay? I'm gonna do the inverse in red. All right, I like to take the values of my original function f, and then I like to flip them all and do my values for f inverse. That's kind of the way I organize myself. So give me some values you notice that are good, distinct points, like on the actual grid marks for f.
-2,
-1. -1, 0 is a good one. 2, 1. And you could have done any of those decimal ones as well. But if you have enough to be able to do it, then you're fine. Give me the inverses ordered pairs then. -1, -2, do not switch any signs. It's just switching the spots. 0, -1, and 1, 2, right? Let's see if the graph comes together. -1, -2, 0, -1, and then 1, 2. Connect, connect. Do they look like they are reflective over this line y equals x? Like I could fold them. Yeah. So you know you did it right if they kind of come together nicely like that. This one looks really like ugly at first. It looks like it's not going to come together, and then all of a sudden I realize, oh yeah, I am. So I'm going to do all these little like the turns here. Okay, let's do it. Negative. What do you guys notice? Is it -3, maybe 2? What's another one? 0, 0. Someone give me these other two so you're thinking for yourself. 3, 1. It looks like 4, -2. Good. Let's go ahead and do inverse. Okay. Where is it? 2, -3. So let's go over here to 2, -3. 0, 0. And that's okay if 1 doesn't change. Especially because since it's reflective over the line y equals x, it goes through the origin. Those origin points just swivel, right? That's where it's symmetric, right? And then what does 3, 1 switch to? 1, 3 I heard. Okay. What does 4, 2 switch? 4, -2 switch to? -2, 4. And at first I'm like, ooh, I don't know if this is going to look like an inverse. At first it doesn't. And then when I really look at it and compare it to the line y equals x, now does it really look like it is the inverse of each other? Yeah, for the most part, right? I mean, I have not very good art skills, but other than that, yeah. Okay. All right, let's kind of fly through this. The hardest part, so right here it says use the graph to evaluate some of these expressions. Are you guys okay to be able to find the input versus output values? But it is kind of hard to wrap your head around where they just have f on the graph and then they're wanting to know what f inverse would have been. Okay, we don't have f inverse graph, do you? I just have f on there. So let's see if we can figure it out. Okay, where's f of 0? What's its output value? 0. Okay, so let's go ahead and find now f. Let's do f of 1 because it's an easy one. Where's f of 1? Good, -9. Well, what if I'm asking for f inverse of -9? Why did you say it was 1? Very good. If I already know that I have a coordinate at 1, -9, well, I know f inverse has a value at -9, 1. So I know that my output would have just been a 1. Let's do this one where we didn't find the first one first. What would you guys say for f inverse of 7? So you're saying it's -1. So how did you get that? Very good. So he realizes this, we got to go find the y value, right? The y value for where he was at 7. So if he goes to 7 here, sorry, the y value is 7, and then he's able to see that it's at -1. Okay? So that one is a little hard to wrap your head around without actually getting a graph. But you got to kind of think, what was the original if supposedly I'm finding 7 what? They're wanting to know what gave me a 7. So we had -1, 7. So if I'm flip-flopping it, 7 what? Oh, 7 -1. Okay? Everybody feel okay about that? All right. Okay, the last I did is being able to do it algebraically. Okay? So algebraically, let's use some common sense for a second. If we have to just sit there and swap out our A's and our B's, what do you think we do algebraically if I know that I want to calculate inverses? I don't want you guys to always have to be able to be like, oh, this operation was adding a 7, so now I subtract a 7. Oh, this operation was times a 2, so now I divide by 2. I don't want you to have to do that because what if you do stuff in the wrong order and it'll just mess up your graph. So let's have like an easy, foolproof way. How do we find inverses? We simply what? Swap the x's and y's, and then we usually have y solve for, so then you just solve for y. That's how easy it is. So write your equation out and make sure you just switch your x's and y's and then get it solved for y. Just make sure you relabel it as f inverse, okay? So if we give it to you as f, label it as f inverse. If we gave it to you as g, label it as g inverse, okay? So because we were just doing this operation, we were doing these backwards operation on the very first slide, okay? So let's go ahead and write this as our x now, and let's write this as our y, and now I want to solve for y. So it looks like we're minusing a 4 and we're square rooting. So what's the inverse of square rooting? Squaring. This is why it's in the backwards order.
I have to square it to undo the square root, and then I have to what with the 4? Add it. So do you notice how everything is its opposite sign? To undo one, we do its inverse operation. This will be labeled as y equals x squared plus 4, but we like things to be labeled as f inverse. So get used to saying f inverse of x squared plus 4. Do you guys feel comfortable to be able to find inverses? So what do you guys think this one's form is going to be in? What's the opposite of minus 3?
Plus 3.
Plus 3. What's the
Isn't that one
opposite
not
of the
1 to 1?
squared? What's that?
Is that one 1 to 1?
It's not 1 to 1. I'm really glad that you noticed that. So let's talk about this one because I'm so glad that you recognize, wait a minute, this wouldn't be a 1-to-1 function because graphically this would be a parabola. Now we aren't making you guys restrict its domain, but in your mind, watch what happens when we try to find its inverse, okay? Y squared minus 3. We have to realize when we go to solve this and I try to undo my 3 by adding a 3, and I try to undo my y squared by square rooting both sides, you typically would have said algebraically that there's 2 results. But this wasn't a 1-to-1 function, and we really should have restricted the domain and only taken from 0 to infinity. So we're only going to take the positive because it isn't a 1-to-1 function. You won't ever write plus and minus when you guys go to calculate an inverse for a quadratic. You'll always just take the plus because it isn't a 1-to-1 function. So you guys will have just said, oh, y equals the square root of x plus 3, which is technically f inverse. Okay? So don't do a plus and minus, I guess, on your homework is kind of what we're saying. Now, I better do C and D or just at least one of them. These ones you have to be a little bit more strategic in getting your inverse. It's a little tricky for kids. So let's talk about this one and how we would approach it. I'm going to go ahead and do C. I might skip D for time purposes, but I'll give you the answer if you want to check your work, because it is a good one for you to practice and be able to have that. All right, let's go ahead and start off by swapping, okay? So I'm going to say x equals a y minus 2 and then a y plus x. So where it gets tricky is I have 2 y's. Do you guys see how I have 2 y's? What would you guys do to get rid of this y plus 1 that's in the denominator? Let's do a different color. We want to, say it one more time. We have to times it. If I want to undo a divide, I have to offset it by a times, okay? So the tricky part is I've got to somehow bring that y with that y, but I can't pull this y out of here. It's stuck to the x. So you have to take a moment and write xy plus x, and then we still have y minus 2. Now the best way to be able to combine like terms is to obviously get them to the same side, and we need to get the y's combined, and even though there's no numbers, there is a way to do it still, okay? So let's get them to the same side. xy minus my y to the left side, and I'm going to go ahead and I want to minus this x over here separate. So I only want my y's together, okay? So I'm going to get a negative x minus 2. Has everybody followed that we just pretty much swapped
question.
those? Yes.
At the start, do we not have to change the minus and plus sign?
Please don't, yeah, because we're taking care of it now.
Oh.
We're doing inverse operations with the solving process. Yep. This is where it gets tricky that I don't love, like, just do the inverse backwards because this is too complicated to view it that way. So that's where we want you just to swap the x's and y's and then just properly solve for y. Great question. Okay, I need my y's isolated. Did you know that because I can't combine x and a negative 1, I actually can factor out a y? This is your strategy. I have now combined my x and my negative 1. I do. I have y isolated now. So this is your guys' strategy when you have binomials, okay, or rational functions. This is your strategy. What's my very, very, very last step to get this completely by itself? Divide by an x minus 1 and divide by an x minus 1. So you guys would conclude that f inverse is a negative x minus 2 over an x minus 1. It's not as simple as just switching every single sign, and there is no really foolproof algorithm. There kind of is, but kids make so many mistakes when we give you tricks. We actually want you guys to just know how to solve it. So make sure you guys are doing that. These can be manipulated differently. Like if you guys had chosen to move xy to this side, you could have accidentally resulted with like a negative, like this could have been an x plus 2, and your negative actually could have been down with that x minus 1, and it could have been a 1 minus x. Like, there's different ways it's manipulated, but it's still technically the same answer. If you guys want to check your work on this F inverse, it's 6x plus 4 over x plus 3. If you guys want to try again, just remember that you do want to make sure you get these x's and y's together, so you always minus them to the same side so you can factor out a y. Sound good to everybody? We technically have learned what you need for the homework, but I do need to go through. I apologize if anybody, can I just work like 5 minutes into flex since I'm gone Tuesday? Is that okay? I want to make sure you guys are confident on this homework, okay? So with inverses, this one is saying use the equation 3x plus 1 to complete this following process, okay? This one asks us to graph f of x. So we have a y-intercept of 1, up 3 over 1, okay, and we graph it. And I want you guys to know, so when we find the equation of f inverse by switching your x's and your y's, and you guys kind of know this process by now, so I'm going to go ahead and just write what the inverse is, just because I think hopefully you guys would be able to solve that just fine. I chose to write it in slope-intercept form, okay? Its inverse would have a y-intercept of negative 1/3, and then up 1 over 3 slope. So I want you guys to see that even us calculating inverses and then graphing them still gets you these graphs that are inverses on a graph. Like if you guys can tell, I did these two really easy linear ones, and look, they are reflective over the proper line, y equals x. So when you calculate f inverse, and if you were to sketch them, they should look like inverses if you guys sketch them. So if your homework has you figure out f and graph it, I want you guys to keep score of that. So the last idea is being able to, I wanted to show you something really quick. I'm not going to take the time to calculate these. I want to hurry and just give you the answers to this. If we take the time to find g of 2, we would have got this to be a 6, and then we would have plugged it in, and so the result would have been a 2. Okay? So g of 2 gave me a 6, and then plugging that in gave me a 2. Well, if I flip-flop this and I say, okay, let's do, where are we at on this one? Oh, are you, okay. When I plug in f of 25, and I get a 27 and I cube root it, it would have been a 3. And then I plug that into g, and I get a 25 when I plug it in. So I would have got a 3 cubed is 27, I would have got a 25. What are you guys noticing when you plug like f? Okay, first off, can you guys tell what these are to each other?
Inverses.
They are inverses, okay? These are inverses. If I took the time to calculate the inverse of this, I would have got this. Because if I add a 2 and then cube root it, they're inverses of each other. What are you guys noticing when we plug inverses into each other?
Well, we're just talking about you.
What's that?
You'll get the same answer.
You get the same answer. Even when you do it with just x. Like watch what happens when I plug f into g. Here's g cubed minus 2, x cubed minus 2, and I plug in a cube root of x plus 2. Well, those cube roots and cube undo each other, and I'm always left with 2 minus, my x plus 2 minus 2, which is just x. So inverses will always, when you plug them into each other, will always result in the x. Inverses undo each other, so your x just essentially comes out of the operation. Okay? So that's something you need to remember about inverses. And actually, when you guys calculate inverses and you want to know if you're right or wrong, you can take this function, plug it into this function, and see if you get x. You can take this function and plug it into this function and see if you get x. If you guys get x, you just prove to yourself you found the proper inverse. Okay? So I wanted to make sure you guys feel completely confident on moving forward with inverses. I do love this problem that has to do with an application of inverses. So I am going to fly through it as fast as I can. I want you guys to look at this. This is a shoe size, and the average height that, is it males? This table gives men's shoe sizes, and it kind of coordinates with how tall this person is and the shoe size that they typically wear. So what's really cool about this is I want you guys to tell me what f of 10 is and interpret this result in your own words for me. Like, let's put this into words. What's f of 10? Hey, babe, Ned. What's f of 10?
71.
Good, 71. Would you guys put in your own words what this means?
The average man that wears a size 10 is 71 inches tall.
Very good. The average man that wears a size 10 is 71 inches tall. Look at how interesting it is and how the sentence changes when it's the inverse, okay? So when it's the inverse, and we hurry and swap all these out really fast, it just tells you a little bit of a different story. It's still similar, but a little bit of a different story when you guys swap these numbers. Sorry, my kid's coming in. I have gone, so I'm making sure they feel solid on these because they're already self-teaching them. So this one says find f inverse of 72. What is it? 11. So put that in your own words now using that input. How would you say?
The average man that wears size
Let's not start with wears. An average man that is 72 inches wears 11. It just switches whatever the input is and what's listed first. Does that make sense? And how your sentence will look. So if you guys on Newton, if they ask you to put it into words, make sure you realize which one's the input and then what is the output. So they're going off of like, oh, the average, they're going off the 72 inches in this case. That's the input and then what the output is. Okay? So if Newton gets a little bit confusing, make sure you're careful about what is the plugged-in part. That's kind of the independent variable, okay? All right, you guys are good.